Okay, so the first thing you should notice on this form right here, let me zoom in a little bit, is you have this little number that's in the radical in this little spot right here. That number is called the index of the root. So let me put a little note here for you guys. Hold on, I gotta let somebody in again. So this little number right here again, this is called the index of the root. All right, so we're going to say that that is the nth root of a, the base is a, to the mth power. All right. Now there is another way to write this in radical form, and I actually prefer this way. So the other way that you write this is you write, well, the a stays inside the radical. And the n is still the index. But then you can put this whole thing in parentheses, and you can put the m power or exponent on the outside, like that. And I actually prefer it when you write it that way. But these are equivalent. These are the same. And then we're going to change that. Both of those are in radical form, and we're going to change that into rational exponent form, which really means we're going to rewrite it as a fraction power. So let me slide over here. So what we're going to do is, first of all, the fraction bar is right here, okay? So we're rewriting it over here to the right. And then that's the fraction bar right there. So you have this fraction bar, and what you guys have to remember is that the index of the root is the denominator of the fraction power. So the index of your root here is a n. So that goes in as the denominator of your fraction power. So the n goes on the and then this other power, hold on, I gotta let a couple people in. So then this power right here, this m, which you could either write inside the radical or outside of these parentheses right here, that is the numerator of your fraction power. So that's supposed to be an m. So it's a to the m over n power. So let's try some of these examples so I can show you how this works. So let's look at 1 and 2. All right, so what we want to do, the main focus of this section, the 7-5, is rewriting these. And in this case, we're going to rewrite it from fraction exponent form. We're going to change it from a rational exponent back into radical form. So the 343 goes inside the radical. like that. And then, again, the denominator is the index of the root. So that 3 right there, that denominator goes in here. All right, and then you could, now when it's a 1, when the numerator power is a 1, well, you could write it like this. When the numerator of the power is a 1. Or usually when it's just a 1, I will put that on the inside of the radical, like right there. So really what you're after on this one is you're after the cube root of 343. So then you got to ask yourself, what number times itself 3 times would equal 343? And I think that that is 7 times 7 times 7. Yeah. So the answer to this one is 7. So the third root, I'm not going to let somebody else in again. So the third root, or the cube root of 343, is 7. Now, if you want to put one of these in your calculator, if you're using your phone, you might not have a cube root. So what you would do is you would write it this way. You would take the base 343, and then you would use this caret key to get the power. But then the power, or the exponent here, is 1/3. So you're going to need to put that in parentheses. So you're going to put an open parenthesis and then 1 divided by 3. Like that. And you should still get 7. Now, if your base happens to be a negative number, make sure you put it in parentheses like that, okay? But let's go on and move to number 2. So again, we're going to rewrite this in radical form. So we're changing from rational exponent form to radical form. So on number 2, the 32 is going to go inside the radical still. The index is a 5. So the denominator of the fraction power is the index of the root. And again, since the numerator of this fraction power, since it's a 1, I'm going to go ahead and just put that inside the radical. And then that's plus. And again, the 9 would be inside the radical. And in this case, the index would be the denominator of the fraction power would be a 2. And again, since the numerator of the fraction power is a 1, I'm just going to go ahead and put that inside the radical. Like that. Okay, so the first one, we need the 5th root of 32. So you got to ask yourself, what number times itself 5 times gives you 32? So that should be 2, because 2 times 2 is 4, times 2 would be 8, times 2 would be 16, times 2 would be 32. So this should be a 2. The 5th root of 32 is 2, plus, and then the next one is the square root of 9. So it's what number times itself equals 9. Well, that's just 3. So you get a final answer on this one of 5. Let's take a look at the next one. Again, if you guys have a question, make sure you unmute and ask, okay? You got to stop me. And then Josh, is there some reason you don't have your camera on? And, okay, Isabel's back too. That's good. Josh, that's not you. Okay, oh, there you go. Thank you. All right. So let's look at number 3. So on number 3, this one I'm going to put the 81 inside the radical. And then the denominator, again, of the fraction power is the index of the root. So that's going to be a 4 for the index of the root. But this time, the numerator of the fraction power here, this is not a 1, okay? So when it's not a 1, I prefer to write it, put the whole thing in parentheses, and then put that numerator of that fraction power on the outside like that. So the first thing you need is you need the 4th root of 81. So you got to figure out what number times itself 4 times would equal 81. And that should be 3, okay? 3 times 3 is 9, times 3 is 27, times 3 is 81. So this should be a 3. So everything inside those parentheses, that the 4th root of 81, that's just 3. So then our final answer is going to be 3 to the 5th power. Well, that's going to give you a 243. Three to the 5th, that would be 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. Then same thing with number 4. So again, inside the radical, you're going to have the 3,125. The index is the denominator of the fraction power, so it's going to be a 5th root. And again, since the numerator of that fraction power is not a 1, I'm not going to put it inside the radical. I'm going to put it outside the parentheses. So then on this one, you got to figure out what's the 5th root of 3125. So what number times itself 5 times equals 3,125. And I believe that one is, I think that's 5. I'll check real quick. Yeah, so 5, so everything inside the parentheses there, the 5th root of 3,125, that's just 5. Because 5 times 5 would be 25, times 5 would be 625, times, did I do that right? 5 times 5 would be 25, times 5 would be 125, times 5 would be 625, times 5 would be 3,125. But anyways, the final answer on this one is just 5 to the 2nd power, so that's just 5 times 5, so it's 25. Again, the main point of this lesson is to be able to convert from this rational exponent form into radical form. All right, well, the next thing we got here is a story problem, but it's not really a story problem. We just have to plug in a number, that's all. So it says, given a cube with a surface area of S, then the volume of the cube can be found by using the formula that's given. And then it says, find the volume of a cube with a surface area of 54. So all they're telling you there is that 54 square meters, that's S, okay? This is S right here. So you're going to take that 54 and you're just going to plug it in for S. Right there. So really not much of a story problem. You just got to plug in the number. So this one you're going to get then the volume of the cube is going to equal 54 divided by 6. That whole thing to the 3/2 power. All right, well, 54 divided by 6, you can actually do that. That's 9, okay? So 54 divided by 6 is 9. So really this is just 9 to the 3 over 2 power. Well, then we'll rewrite it in radical form. So the 9 will be in the radical. The index is the denominator of the fraction power. That's a 2. And since the numerator of the fraction power is not a 1, I'm going to put it outside of these parentheses. All right, well, then we just have the square root of 9. Well, that's 3. So inside the parentheses, the square root of 9 is 3. And then that's still going to be to the 3rd power. So the final answer is 3 times 3 times 3, which is 27. Again, if you guys have any questions, just unmute and give me a shout. The next thing they want us to do is fill in this table, but we're actually going to skip that for now. I don't want to confuse you with that. Maybe tomorrow at the beginning of the hour, I'll fill that in with you. But let's just do these last 3 problems at the bottom of the page. We're going to do the same thing that we were doing with numbers, but now we have to do it with variables. So let's look at number 6. Okay, so number 6. So number 6, I'm going to rewrite this with a fraction exponent. Okay? And how I'm going to do this is I'm going to think of this one like this. I'm going to make this this whole thing to the 1st power, like that. Well, if I do that, then I'm going to have a to the 4th times b to the 20th. That whole thing would be to the 1/4 power. Again, the denominator of the fraction power is the same as the index of the root. So the denominator of this fraction power is the same as the index of this root. And then this power on the outside of the parentheses, that goes in the numerator right here. Well, now that I've done that, then I can apply one of the rules we had from before the break. So then what I have to do is I have to apply this power to the a to the 4th and also to the b to the 20th. So then that would look like I would have a to the 4th to the 1/4 power, and then that would be times b to the 20th also to the 1/4 power. And now what we have is we have a power raised to a power. So if you look back at those rules that we talked about at the beginning of today, that is this rule right here. So when we have a base where we have a power raised to a power, we're going to multiply the exponents. So let's go back to this one. So then I'm going to multiply these powers, and I'm also going to multiply these powers. Well, multiplying by 1/4 is the same thing as dividing by 4. So really what I get here then is this is a to the 4/4 power times b to the 20/4 power. Well, then 4/4, that's just 1. So this just ends up being a to the 1st times b to the 5th. Because 20 divided by 4 is 5. So that's number 6. Let's take a look at number 7. So number 7, I'm going to take this 1/2 power, and I am going to apply that to both the x to the 6th power and the y to the 4th power. And then what I want you to notice on the square root right here, I didn't tell you this earlier, but if you have a radical and then there's no index given right here in this spot, then that's implied to be a 2. It's going to be a square root. So it's implied that this index right here is a 2. All right. So let me rewrite this thing for you guys. So we're going to have x to the 6th to the 1/2 power. And then we're going to have y to the 4th to the 1/2 power. And then we're going to rewrite that radical in fraction exponent power as a fraction exponent power. So we're going to have y. Well, the numerator of the fraction power is this 2 right here. Let me do that a different color. So this 2 right here, this green 2, that is the numerator of the fraction power. And then that blue 2 right here, the index, that is the denominator of the fraction power. So it looks like that now. Again, right here, we have a power raised to a power, so we're going to multiply the exponents. Again, multiplying by 1/2, that's the same thing as dividing by 2. So that's just going to give us x to the 6 over 2 power. And then we're going to have times y to the 4 over 2 power times y to the, well, right here you can see if you got 2 divided by 2, that's just 1. So that's going to be a y to the 1st power. Well, that'll give us the power on x is 6 divided by 2, so that's a 3. The power on this first y factor there is 4 divided by 2 is 2 times y to the 1st power. Well, now you're going to multiply like bases right here. You have y to the 2nd times y to the 1st. And that takes you back to this rule right here. This was out of 7-2. So if you're multiplying with the same base, you add the 2 powers. So the exponent will be n plus m. So then in the one we're doing, this is going to end up being y to the 2 plus 1 power. So then our final answer on this one is just going to be x to the 3rd times y to the 3rd. So you end up with x cubed, y cubed. All right, then we're on the last one. So last one for today is number 8. So number 8, the first thing I'm going to do is I'm going to apply that second power on the outside of that product. So this second power is going to go on this x, and it's also going to go on this y to the 1/2 power. So then that's going to become x squared, and then y to the 1/2 to the second power. And then in the denominator, all I'm going to do is I'm going to rewrite that radical with a fraction exponent. So again, you have x, and then the 10 right here, so that blue 10, that is the numerator of the fraction power. And then this green 5 here, the index, that is the denominator of the fraction power. Hold on, I gotta let somebody back in. All right, well, let's try to simplify this then. So then we have x squared, and then we have y. Well, again, right here we have a power raised to a power, so we are going to multiply these. So 2 times 1/2, that's just 1. So that's going to be a first power. And then in the denominator, we have x. Well, 10 divided by 5, that's just 2. So that exponent is just a 2. Now notice here, we have x squared divided by x squared, right? Well, one thing we could do is we could apply the exponent rule that we learned on Friday before break. So if you go back up, that is right here. That's this one. So when you're dividing with like bases, you take the numerator power minus the denominator power. So if you do that on the one we were doing right now, this would be x to the numerator power minus the denominator power. Well, that would just give us x to the 0 power. Well, what's any number to the 0 power? Pardon me?
You said 1.
Yeah, good. Yeah, that's 1. So that's a 1. But again, you could have just looked at this and you could have just said, if I've got x squared over x squared, right? Anything divided by itself is going to be 1. So really, these just cancel out right here. That's a 1. So I end up with just an answer of just y to the first power, which is just y. And then that'll do it for today. So let me stop recording here, and then I'll write your assignment for you.